Yeah, 1 day. Okay, so the last type of problem we're going to look at is questions that involve distance and time, or distance, speed, and time. Okay? So let's take a look at what question 1 says. So it says, Timmy rows 20 kilometers downstream in 3 hours. On the return trip, it takes him 4 hours to travel 15 kilometers. Okay? Determine his average rowing speed and the speed of the current. Again, when in doubt, that last sentence always tells you what you're trying to find. So whenever we've been solving these word problems, step 1 is to write let statements. So what would be the 2 unknowns here? Yeah?
Let D represent the distance in kilometers?
No. I know the distance.
Okay, well...
Okay, you gotta listen to what I was saying. Just 1 second.
Okay.
I said look at the last sentence. That always has a clue, or it basically states what you're trying to find. Ariana?
Let S represent speed
of
current.
Okay. How many speeds are there?
2.
So maybe we won't use S because that might get confusing. So maybe we'll go let R be the speed of the rower, or the speed of the boat, and let C be the speed of the current. Let R represent the speed of the rower, I'll say, or the boat. Okay, and let C represent the speed of the current. So, have all of you had an experience where you've been in a boat? Have a canoe and you've had to paddle? Okay. So, have you noticed that it's usually easy to go one way and harder to come back? And that's what the current means, right? If there's no current, that means it would be the exact same time to row one way and the other. But if there is a current, then one way the current helps you go faster. The other way, you're fighting against the current, so you have to realize that overall, even though you might be rowing at the same speed, you actually end up going slower because the current is working against you. So we are dealing with speeds, okay? R and C are given speeds. They're fixed. We just need to figure out what they are. The speed that Tim rows is fixed. The speed that the current is going at is fixed. So we need to come up with 2 equations that relate these 2 speeds. I'm going to write something here.
That's what we did in science.
Yeah, remember way back in science, we looked at, I think in science we didn't really do distance, speed, time, but we did, there's a lot of relationships that can be written like this with your voltage and your current and all that kind of stuff.
Density.
So distance, speed, and time also are related in this fashion. This should not be a shock. If I want to calculate the speed of something, I cover up S, speed equals distance over time. If I want to calculate the time of something, it's distance over speed. If I want to calculate the distance of something, speed times time. So if I know the speeds of the rower and the current, if they're working together, am I going downstream or upstream? If the 2 speeds, like downstream. Okay, so let's deal with this downstream scenario first. So Timmy is rowing at an R speed. The current is going to help Tim row downstream, so you're going faster. So right now, R plus C would be a total speed of rower plus current together. I now need to know what would be the total speed together. Well, they don't tell me the total speed, but they do say that Timmy rowed 20 kilometers in 3 hours. Can we somehow come up with a speed based on that, Kennedy? Yeah. Everyone okay? Why is that true? Because what did we just say? Speed equals, so speed of rower plus speed of current equals total speed. The total speed is they end up going 20 kilometers in 3 hours. We'll leave it as a fraction because if we start rounding at this point, we'll lose accuracy. So we'll leave it like that. That's going to be my equation 1. Equation 2. So always start with the rower or the boat or the plane or whatever is fixed. Always start with that. The current is what's going to change. Because if I'm going upstream, okay, I'm going upstream, what do you think happens? I'm rowing at the same speed, but the current is working against me, so my overall speed will be less. How do you think I write that? Instead of the current helping me go forward, it's taking away from my forward movement. You got it. And now, we're just going to take it as it is. They've given us the information. Apparently it doesn't go all the way back to where he started. He's only going 15 kilometers in 4 hours. But again, can I write that as a fraction? Good. There's my equation 2. Yep.
Would it make sense to like put it up to 20, like take the fraction and make it even to the other fraction to increase it?
Well, you can, or again, right now, we could, okay, so maybe something smart to think about here is, so I now want to work with these 2 equations. I've done the hard part. I've come up with the 2 equations. But now I want to do either substitution or elimination. But maybe first, before I do that, maybe I want to clear the fractions. Do you want to clear fractions?
Yeah.
Now, I'm going to kind of go with what Joe's saying because there's a little bit of a little bit of an idea here if you think about it. So, if I want to be able to set up, well, okay, let's if we clear the fractions separately, which is fine, what would I be multiplying the first equation by?
3.
If I multiply everything by 3, would the fraction be cleared?
Yeah.
The second equation, if I multiplied by what, the fraction will be cleared?
4.
So that's totally fine, but the one catch would be, I'm going to have 3r plus 3c, 4r minus 4c, so I'm still not going to be able to eliminate yet. Yeah?
Then you would just do it again.
Why don't we pick 12?
So it sets it up automatically.
Why? What happens if you multiply the first equation by 12? What's now going to be in front of the r and the c?
12R and 12R.
12?
And 12C and 12C.
And 20 times 12 over 3. Remember, you can do the dividing first to do it in your head. 12 divided by 3 is 4 times 20, 80. And now I multiply each of these by 12. 12r minus 12c. And 12 divided by 4 is 3 times 15. Am I good to go for elimination?
Can we eliminate the C's?
Or the r's, right? You guys get this is kind of neat.
Sign is-
You add, you're going to eliminate something. You subtract, you're going to eliminate something. Like this one, it works out both, either or. So what do you want to eliminate, C's or R's?
Let's do
Let's do this to be different. The C, if I'm going to eliminate the C's, I have a plus and a minus. So what would be the operation? I need to add to eliminate the C's. 12R plus 12R.
24R equals
80 plus 45.
Yeah, 100 and
Okay, so R equals 125 divided by 24. At this point, let's go into decimal mode. So 125 divided by 24. 5.21 approximately. Okay. Now, I have a rowing speed of 5.21. Can I find C? And again, you can use original equation 1 or 2, or you can use your one where you multiplied by 12. Original? Sure. Which one? Original 1?
Yeah.
Original 2? So substitute R
Would you do
equals
equals or
5.21. I'm going to put approximate. R is approximately 5.21. in 2. So that's going to be 5.21 minus C. And now in this case, since we have a decimal number already, let's turn at this point 15/4 into a decimal number, which actually works out kind of nice. It's 3.75. And I want you to understand, like, hopefully this is making a lot of sense. My rowing, the Billy's rowing at this speed. There's some current that's going to take away from his speed so that the overall speed is 3.75 kilometers per hour. So now just find that missing current speed. So if you guys want to kind of do a little double switch here, we'll bring C over here and 3.75 over here. So 5.21 minus 3.75 equals C. And C is 5.21 minus 3.75, 1.46. So, conclusion, therefore, again, the question was, what is the average rowing speed and the speed of the current? Therefore, Billy's average rowing speed is 5.21 kilometers per hour, and the speed of the current is 1.46 kilometers per hour.
Wouldn't it be approximately?
It would be approximate. You rounded 2 decimal places, so if you didn't write the word approximate, I wouldn't necessarily deduct a mark, but you did round, so these are a little bit, because they rounded, they are approximate. All right, so again, quick thing you could do is 5.21 plus 1.46, 6.67. Figure out if that's what 20 over the first number, right? 20 over 3 is. 20 divided by 3, 6.66666. Oh, makes sense. 6.67. 6.67 is approximately 6.66 repeated. Okay? All right. And then again, 5.21 minus 3.75, 1.46, which we said is correct, or sorry, it should have been 5.21 minus 1.46 is 3.75, which is exact. All right. So in the case there, the numbers didn't work out perfectly, so don't be, again, doesn't always work out perfect, so don't always think that's going to happen. Let's try it again. Let's do another one of these boat questions. It says, a boat traveled 210 kilometers downstream in 10 hours. He traveled the same distance back, or the boat traveled the same distance back, but it took 70 hours. Okay? What is the speed of the boat in still water? What is the speed of the current? Okay? So it was a really slow travel back. Like speed downstream, and then took our time coming back upstream. Okay? So, shall we do, is our setup pretty much the same as it was before? Yeah. Yeah, I know, it should be more itch. Yeah, technically boats are supposed to be she's, right?
Why does the boat need a gender?
It's probably just a typo. The boat traveled the same distance back. Okay, yep. Yeah. Okay. Oh, that's up. Okay, they're probably, okay guys, let's not just get buried in semantics here. Probably there was a person and we got forgotten.
All students who are signed up for confession, including grade 9 vocal students, all students signed up for confession, plus Ms. Richard's vocal class, please meet immediately in the atrium to leave within the next 2 minutes. Please come to the atrium ready to go to the church immediately. Thank you.
Okay guys, we're writing out our let statements. We're letting B represent the speed of the boat and in still water, and let C represent the speed of the current. Okay? Okay. So, it's basically, do you guys get the setup of the left side is going to be the same for any of these type of boat current questions, okay? You have the boat speed as fixed. Boat can go a certain speed. If the current is with you, if you're going downstream, so the current is with you, what does the current do to your boat speed? Makes you faster, so you add them together. And now I need the total speed of with the boat and the current together, so resulting in traveling what distance in what time? Yep. Good. 210 kilometers in 10 hours. So I have B plus C equals 21. So now we're coming back. We're doing the slow journey back. And it's traveling your same distance, but it took 70 hours. So, super slow trip back, B minus C. It's going to be
210 over 7.
Yeah. And that becomes B plus C equals? Yep. Oh, whoa. B minus C equals? Okay. Does it make sense? Okay, guys? Isn't it just 3?
Yeah, it's
Yes,
three.
Because that didn't make sense. So it should make sense, because here's what this is saying. You go downstream pretty fast, almost only 10-hour trip, and the overall speed of the boat speed with the current speed together is 21 kilometers per hour. We're doing the slow journey back upstream, and the current is hindering my boat's progress, so I'm going at a slower speed. My overall speed is only 3 kilometers per hour. Okay? So now, let us figure out the answers. Do you like the fact that because my answers weren't fractions, am I ready to go for elimination? You guys really into eliminating C in these two questions. Shall we eliminate C again?
No, substitute B. Substitute.
No, I'm done with substitute.
I like
Oh, now you're done.
No, we can substitute if we want, but
substitute.
I'm going to add, again, adding is, you'll avoid negatives if you add. That's the nice thing, right? If you technically, you actually avoid negatives if you subtract. I don't care. Do you want to add or subtract?
Add.
All right, I already wrote a plus sign. B plus B, or not to be. C plus negative C. 21 plus 3.
24.
B equals.
B equals 24 divided by 2.
B equals. Okay, so B equals 12. Guys. So B equals 12. Substitute B equals 12 in?
1.
Sure. 12 plus C equals 21. C equals. C equals. Speedy current. Okay? So, okay, so therefore, the boat's speed is 12 what? 12
Kilometers per hour.
kilometers per hour, and the current speed is 9 kilometers per hour. Okay, flip the page and you try the question. We're going to take it up in 4 minutes. Go. Yeah, sure. Okay. Yeah, you can switch around, you can Amen. Yeah.
Did you mark the AP quizzes?
Now that they're all marked, they're all done, I will have them back for tomorrow. Huh?
That was the,
I have the time. Yeah, you like that. I'll give those back in a second.
Try to not blame you. Try to not blame you.
Okay. Press pause. Okay, be back to do the last example in a, so pressing pause now. Okay, so if you take a look here, guys, here's the final answer to number 3. You should have got that the plane is traveling at 135 kilometers per hour and the wind speed is 23 kilometers per hour. And these are not really easy to check. Just add and subtract to check to make sure you got them right. Okay? Now, the word problem sheet that you've been working through over the last 2 days, you're going to finish it off. The first 3 questions, so 19, 20, or what is it? 19, 20, 21 are very similar to the ones we just did in class. Now, the last 2 are different. They aren't going to be set up the same. And if you look at the last 2, the unknowns aren't speeds. The unknowns are either times or distances. I can't remember which.
Oh, so it's basically
the opposite.
finding it's the opposite.
You have tomorrow, today, tomorrow, Thursday, that's not right. Okay? So, the idea is, I'm going to go back to that triangle, guys. If you're told, okay guys, please listen. Let's read 22 just to get a feel for what we're talking about. Someone have 22 handy, I can just read.
Go ahead. Oh, darn it.
Okay. Okay guys, listen to 22. I'm going to read it, and then let's see if you can figure out what the unknowns are. It says, on weekends, please listen guys. On weekends, as part of his exercise routine, Carl goes for a run, partly on paved. Hey guys, okay, we're not going to do it then, right? On weekends, as part of his exercise routine, Carl goes for a run, partly on paved trails and partly across rough terrain. He runs at 10 kilometers per hour on the trails, but his speed is reduced to 5 kilometers per hour on the rough terrain. One day, he ran 12 kilometers in 1.5 hours. How far did he run on the rough terrain? So, for a question like that, do you get that you know the speeds this time? Speeds are known. What you are asked to determine is how far did he run on the rough terrain? How far? What do you think I want? The distance. So you're going to, just as a little bit of a hint, guys, if I say let, I don't have time to do full let statements, but you would do, well maybe I do. Let R represent distance on rough terrain. What's the other type of distance he's running? He runs on rough terrain. Let P represent distance on paved terrain. Okay? Now, please watch, guys, or else you're not going to be able to do these. Okay. I know he traveled P kilometers on paved. Let's wait. P kilometers on paved, R kilometers on rough. What happens if I put those two distances together? He traveled 12 total. We know another total, the total time. And I somehow write two expressions that mean times, time on page plus time on rough equals total time. Think about this. We'll take it up tomorrow. What's time? What's time? Over. So fractions are going to show up. Have fun. Bye.
Bye.